So, when we talk about the limit, you might, from the previous lesson, we learned all about when things stop to reduce, when people's drop and then stop, or people's grow and then stop. This has a mathsy term, I think it's called just basically the limit of the function. Um, but basically, how do we know when something contains a limit or does not contain a limit? Well, if you were paying attention in the last example with Excel sheet, you'll notice that there was a difference between the types of equation that went to infinity or negative infinity and those that went to a constant rate. So what does this mean? Well, let's see if there is a way we can figure out what this limit is going to be. Okay, so let's have a think. So a limit. Okay, what's the best way to explain this? I should probably know. I'm the one teaching you. Okay, so we started off with our normal expression, un plus 1 equals a un plus b. Okay? Well, if we know that if we just keep going, it's going to reach a value of a limit. Okay, so basically this number, un plus 1 and un are just going to be the same, because no matter how long you go, the number just stays the same. So, if you just take this example here, you can keep going from here to infinity, and this will just stay the same. So we can call that the limit, okay? So what happens then is this side, L, becomes equal to A, well, and then instead of un plus 1, well, un plus 1 and un are actually the same, so you can both call them L. So this becomes plus B. Then this becomes a little bit of algebra. So what you want to do is you want to move the AL to the other side of the equal sign. So you have B, take out a common factor of L, so you have 1 minus A equals B. Then you have an expression for the limit, which is B over 1 minus A. Okay, this is it here, and sometimes it helps to put this in brackets in your calculator. Okay, well, are there any problems with this? Well, what if A is equal to 1? Well, what's going to happen there is this is going to become 0, and that's going to be undefined, so A cannot be equal to 1 for this. But what else do we need to think about? Well, we need to realize that for a linear recurrence relation, that A needs to be in a certain range of values. And again, if you go and play about with the spreadsheet, you'll be able to figure this out for yourself. But basically, A needs to be in the range of -1 to 1, okay? And this means that it will tend to a limit, okay? A needs to be in this range, because if you put a number that is bigger than 1, it means that this will not have a constant value. This will not reach a limit. We can do some examples if you'd like to see that, but this is really what you need to take away, that this limit needs to exist between here and here, because if you don't have it in that range, then it won't form this pattern or that pattern, and it won't reach a limit. It will just keep going to infinity. So I really like understanding this expression, because if you understand it, then you don't need to memorize it. This isn't given the equation sheet, so it makes a really good point to actually understand how you get it, and that way if you forget it in an exam, you can just work it out again for yourself. So to sum up, for a linear relation, un plus 1 equals un plus b. If a is in between -1 and 1, then un tends to a limit. Now this is the kind of thing you ask the exam all the time, to show that this tends to a limit. Then you have to write a little statement that says, as a is between -1 and 1, the trend to a limit of whatever it is. And this is calculated by using this expression here. So take the example of the trees. You know the trees was un plus 1 was equal to, what was it, 0.8 a 0.8 un plus 10. So we could have told you off straight away whether this was gonna reach a point where there was no more forest. So we can already see that this number is between -1 and 1, so we know that there's going to be a limit. So all this becomes 10 over 1 minus 0.8, so that equals to 10 over 0.2. And what does that give us? Definitely work this out in your head if you wanted to. 0.2 equals 50, which makes sense because that's what we thought was going to happen. That's what we saw in the thing. The limit for that expression would have been 50.